This is 4.2. We're going to dive into solving quadratic equations by graphing. Keyword there being solve, right? So last section we were just graphing, and this time we're going to see what part of the graph can clue us into solving these quadratic equations, okay? So we saw this image in the last section. We're familiar with the vertex and the axis of symmetry. All right, the vertex, remember, is your peak or your valley. It's your maximum or your minimum appearing either at the bottom or the top of a parabola. If it's one that opens down, then your maximum would be up here. Axis of symmetry is that dotted line that divides the parabola in half. It passes through the vertex. So remember, your vertex is going to be a point, x comma y, and then your axis of symmetry is going to be x equals a number. And then that number is whatever your x value of your vertex is. All right, and then talking about the x-intercepts and the y-intercepts of a parabola is where we're going to pick up today. So the x-intercepts are these two spots here on this graph, right? So it's wherever the parabola crosses the x-axis. Those are also sometimes called zeros, roots, or solutions. And we're going to see going forward that wherever your parabola crosses your x-axis, those are your real solutions, all right? And your y-intercept, if your parabola has one, it's wherever it crosses the y-axis. If it's a parabola opening up or down, it's only going to have one y-intercept. If it's a parabola that opens to the right or to the left, then it could have the potential for having two y-intercepts. Okay. So remember that no matter what, whenever you're finding an intercept, no matter what kind of function it is, just plug in 0 for the opposite variable. So if you want to find your x-intercepts, you're going to plug in 0 for y. And if you want to find your y-intercept, you're going to plug in 0 for x. Okay. So let's take a look at this. All right, so we're given a quadratic equation in standard form, y equals x squared plus 14x plus 45. Let's find the vertex first. Remember that your vertex can be found by taking negative b over 2a, which would be negative 14 over 2, which would be negative 7. So if we plug in negative 7 to this original equation, then we are going to get negative 4. Right? So our vertex is going to be over at negative 7, negative 4. Right here. Okay. Our axis of symmetry is that that vertical dotted line that crosses through your vertex. All right, just like that. And then we're going to see our parabola either open up or open down. Since this has a positive leading coefficient, it's going to open up. All right, so our axis of symmetry here is x equals negative 7. It's a line. All right, and so to find our intercepts, we're going to skip that for right now. We'll use a graphic approach to help us find those in just a second. And to get our y-intercept, let's plug in 0 for x. All right, so let's plug in y equals 0 squared plus 14 times 0 plus 45, meaning that our y value would be 45, so our y-intercept would be at 0, 45. We're not going to be able to graph that on here. Our axes only go up to positive 10, but that's what our y-intercept would be. Okay, so let's continue graphing this like we did last time. Let's make our x, y table, right? And then let's put our vertex in the middle and find some points on either side. So let's go, let's see, up to negative 6, down to negative 8, up to negative 5, down to negative 9, and that's where we're going to see our symmetry start to appear. All right, so if we plug in negative 7, then we get negative 4. If we plug in negative 6, we get, we'll leave a negative 3, which means that when we plug in negative 8, we'll also get negative 3 because that's symmetry. And I'm going to go ahead and plot these points. All right, and then if we plug in negative 9, we're going to get 0. If we plug in negative 5, we're also going to get 0. All right, right here. So let's draw our parabola. Oops, I missed that point right there. Here, it's a little better. There's our parabola, and our solutions then are these x-intercepts, all right? So our x-intercepts, if we're looking at this table, we see they're -9, 0, and -5, 0, meaning our solutions are x equals -9 and x equals -5. Okay. So this key concept, x-intercepts are the solutions of the equation. So whenever I ask you to solve an equation, in general, like think about back in, Algebra 1, if you saw x plus 3 equals 3, then when you solve for x, get it by itself, x equals 0, that's an algebraic way, and then this is the graphic way to do that. All right, just look and see where does your graph, where's your function cross the x-axis. All right. So algebraically, we will do this by plugging in 0 for y, and we're going to build on this in the next section. But here's a process, right? We're going to get all variables on one side so that the equation is equal to 0. That is very, very important. Put a star by that. Then we'll factor. So factoring is going to come back. Might need a little practice with that if you've forgotten how to do it. Then we're going to set each factor equal to 0 to get the solutions, right? And so we can do this because if two numbers multiplied together equal 0, then one of the numbers has to be 0. So let's see what this looks like in an example. We're going to solve x squared minus 3x plus 2 equals 0. So this is an equation. Our first thing is gonna be to factor. All right. So thinking about factoring this, as we get better at factoring, we will go through these more quickly. All right. X minus 2 and x minus 1, because minus 2 minus 1, when I combine those like terms, if I were to FOIL it, I would end up with -3x. And then if I multiply -2 times -1, I'd end up with this plus 2 here. Right? And then so think about this for a second, all right? So we're saying that some quantity times another quantity equals 0. So either this quantity has to be 0 or this quantity has to be 0. Well, that has to be true, all right? So we're going to set up those two options. X minus 2 equals 0, x minus 1 equals 0. We're going to have two possible values for x. X could equal 2, x equals 1. And that's that. So you just take each factor. As long as this is all multiplication, nothing else is going on this side of the equal sign, and it's equal to 0, you can set each piece equal to 0. You can only do this when the equation is equal to 0. All right. If this said x minus 2 times x minus 1 equals 5, you could not do this. All right. You could not say that x minus 2 equals 5 and x minus 1 equals 5. That is no good. All right, you have to only do it when it's 0 because of that idea that one quantity has to be 0 or the other quantity has to be 0. We're going to skip this one. It's a misprint in your notes. All right. Pause the video. Give this one a try. All right, what's different about this one? Hopefully you've wrestled with it a little bit here. We're not equal to 0 yet. All right, so the first thing we have to do is move everything to one side so that we are equal to 0. Then we can factor using the AC method. All right, 4 times 3 would be 12. So think about what are some factors of 12. 1, 12, 2, 6, 3, 4. All right, and then I'll do this expanded version. 4y squared. We want this 12 and 1 situation. All right, plus y plus 12y plus 3 equals 0. If you don't remember how to do this, then you got to go back and review factoring, all right? And then we're going to factor by grouping, and then because these two terms are equal to each other, these two quantities, we can rewrite them as 1. 4y plus 1 times y plus 3 equals 0, meaning, change colors here, that 4y plus 1 equals 0, y plus 3 equals 0. Solve for y equals -1/4, y equals -3. All right, and so we can also use a graphing calculator to do this. I want to get us more familiar with using a TI-84. So that is where we are headed. For now, though, we can, in this video, look at Desmos and see how to do this. So 4x squared plus 2x minus 3. And then to get the x-intercepts, you just click on them. It shows them pretty nicely in Desmos. And then to get the vertex, Desmos also highlights that for you. Right? So then you would just label them. On here, you would say, all right, my vertex is -0.25, comma, negative 3.25, and you would say that my x-intercepts, which are your roots, your solutions, are the following: negative 1.151, 0, 0.651, 0. All right. And that's all we're going to go through. All right. Your notes have a little bit more about a TI-84, TI Inspire, which we will hopefully go through as a class.